Good evening to all. Today is the day 6 for this seminar. Today we'll discuss about the how to design the same beam and column design in. Yesterday we'll discuss about the normal design. But today we'll discuss about the advanced RC designs. Okay. Today we'll discuss about the how to design your frame into RC design. Then let's discuss about the how to analyze your foundations also. Okay. Okay, fine. Next step, how to analyze the your column beam design in advanced RC designs. Okay, advanced RC designs in beam and columns. I simply go for this concrete design. Simply click this concrete design. Design. Again, once I open it, I simply go for analyze. Then go for give this done. Then go for my concrete design. This is my concrete advanced RC designs. Okay, this is my page was I designed my advanced concrete design. Yesterday we'll discuss about the normal design. This is the advanced concrete design. We will take the beam reinforcement details, column reinforcement details, and all the things. Okay. Okay, how to design your beam design in advanced RC design. These are the five procedure will be follow, five steps. One is the you create an envelope, second one is a member, third one is a group and brief, finally the fifth one is the analyze. Okay, this is the five procedure to design your advanced RC elements for beam and column for your elements. Okay, first of all, I analyze my beam. I simply go for my first step is a envelope. I simply selected my envelope. This is already the envelope table is there. So I create my new envelope. I simply click this new envelope. I put my name on beam design. Okay, this is my beam design. I simply enter my new envelope name is the beam design. I simply click OK. Beam design, this is a combination load. The combination load is changes into envelope. Sometimes it's have only not a combination load. I have a different load only. Simply untick this. Automatically or different loads are available. But I have a combination load. I simply select my combination load, change into envelope side. Simply click this arrow button, then automatically you change into your combination loads. Okay. You simply change in your combination load. Simply click OK. This is the first step. The first step is the envelope creation. The first step is the envelope creation. Go to new envelope and then go to edit option. Transfer to your name on this side. This is the first step. Our second step is the numbers. Which number you will be selected for your beam and columns. Okay. The next number is selected for your columns. This is second step. Second step, I selected my beams. I simply go for members option. I simply go to members option. Then I selected this beam. Control, I selected the three beams. Okay. I simply selected three beams or four beams. All the floors, I simply selected the second step. I selected simply selected the all the beams also. Then go to how to identify this number. First of all, I simply select this number. Then how to identify your number? Simply go to member, select this number, then click this auto form number. Simply click this number, then go for auto form number. See this automatically your member will be added. M1 is the name is the M1, M2, M3, M4. There four number will be created. Since I simply created the four numbers. M1, M2, M3, then M4. There four numbers will be created. That is the second step. Second step is a member creation. The first step is a envelope creation. Then our second step is a member creation. The next step is a groups and created. Next step is a groups and briefs. What is by groups and briefs means the groups and briefs is same like that. The groups and briefs is the same like that. You will be created the you will be created the same like that concrete values grade of concrete and a grade of steel, that type of works you will be created the same like that in group and briefs also. Okay, what is in by groups and briefs? Same like that. You will be apply for your grade of concrete and reinforcement, all the designs. It will be given in this advanced RC elements. Okay. I then simply go for my group and briefs. Okay. I simply go for my groups and briefs. First of all, I simply select my new brief. Okay, first of all, I go to simply select my new brief. Then this is our name. B1 is the name for my B1. It's a brief. The my brief B1 is the beam designs. Okay, I simply selected my beam design. Automatically, I enter my name is a beam design for this area. I simply selected the name is a beam design. Then go to check your code, design code for your beam design. Our code is a IS456. Okay, our code is a IS456. Simply go to, you take this size. My code is a IS456. Select this automatically. Our code is a IS456. Next one is a design type. Our design type is a beam. It will be designed only for beam and column only. As per IS4 physics, you go for slab, it take a British standard. But you go for Indian standard for your beam and column, you will be go for your only for IS standards. I selected my beam design. First one, new group, you selected your beam design. The next one, design code is the IS456. Next one is a design type. The next one, design type is our beam design. Then simply click OK. Simply click OK. Then give the same values for your design areas. How to give the design areas? Same. Your grade of concrete, reinforcement, steels, and all the values. Okay. First step, your cover for your top side and bottom. The three sides, it will be provided the cover. Our cover is a 25 mm. I provided the top and side bottom also. Three sides I will be provide my cover is a 25 mm, 25 mm, 25 mm cover also. The next one is the minimum reinforcement spacing. I provided the 40 mm. Okay, minimum as per IS. Let's discuss. Before day yesterday, sorry, previous section will discuss about the minimum spacing of the reinforcement bars and the maximum spacing also. I take this 40 mm. Then I choose my grade of concrete. I choose my grade of concrete. I M25, M30, M40 is there. My grade of concrete is a M25. I simply select my grade of concrete is a M25. The next one, this is a beams design option is a vertical bending and shear also. Vertical bending and shear. Only the earthquake will be the lateral bending and shear. It's only the vertical bending and shear. Then our grade I change into M25. Then go for is divided into 12 segments. The simple method, your beam is a 4 meter, the 4 meter is divided into 12 segments. That is called 12. My beam is 1 meter beam. The 1 meter beam divided into 12 segments. You not only 12, you go for 20 or 5 or anyone based upon your conditions. Okay. I divided into 12 segments. Then design for torsions. Okay, I simply select the design for torsion. The envelope. Our envelope is a beam design. Okay, our envelope is a beam design. Next one is a reinforcement arrangement. Same like that. Next one is a reinforcement arrangement. Your minimum reinforcement, I provided the 12 mm for top bar. Already previous section will discuss about the manual also. What is in by top bar and the bottom bar also. I provided the minimum size of my top bar. I provided the 16 mm dia. Provided for my top bar. Then our maximum size of the bar is a 20 mm. I provided the maximum size of the bar is a 20 mm. The hanger bars also 12 mm. I simply provided the hanger bars also 12 mm. Then I provided the reinforcement gap between 32 mm. Okay. The reinforcement gap, minimum gap is a 32 mm. I will provide it. Then bottom bar criteria. Same like that, the bottom bar criteria. The bottom bar, the minimum size I provided the same like a 16 mm. The maximum bar I go for 20 mm. The hanger bars also 12 mm. Okay, 12 mm. Minimum spacing is a 32 mm. Then you go for your bar type. Bar type means FE415 or 250 or 500. I simply selected my bar type is a FE500. Okay. FE 500. Then our sidebar criteria, I already tell about the more than 750 mm is the sidebar criteria will be used. It's automatically your beam depth is more than 750 mm is automatically it's calculated the sidebar criteria. The sidebar criteria reinforcement is a 12 mm, but my all the beam size are maximum only 400 only. But your beam sizes go for maximum 750 mm. You will be designed for this reinforcement. This is the second step for your main reinforcement. You provided the top bar minimum and maximum reinforcement and bottom bar minimum and maximum reinforcement for your bars. Then shear reinforcement. Already discussed about the shear reinforcement. The design for shear, the central line of the support used for your shear on column face will be provided the central line of the support. Next one, shear bar criteria, the stirrups bars. I provided the steps for bar 8 mm or 10 mm or anyone. I simply provided my stirrups for 8 mm dia size. I provided the 8 mm dia size. Then go for number of legs, 2 legs, 3 legs, 4 legs, 5, 6 is that. My stirrups legs is a two-legged stirrups. Okay. My stirrups is a two-legged stirrup. I change it to minimum spacing is a 40 mm. Then this is a closed stirrups. Okay, this is a closed stirrups. My grade of stirrups is a 415. My steel grade of stirrups is a 415. Then it's a shear reinforcement. I change my shear reinforcement. This is our main reinforcement. This is our general reinforcement. This is our main reinforcement, shear and general reinforcement also. Then simply click OK. Once you simply click this all the value, it will be give OK. Then you go for new design group. Then you go for new design group. Simply select this design brief, click this design beam, then click OK. This automatically it's created the design beam also. This is a design group. Design brief is a you selected, then you change your grade of concrete and all the values, main reinforcement and shear reinforcement also. Then simply go for a new group, select this, add this beam design, then created the groups and briefs. You design the slab also, but it's a slab is taken from British standard, not Indian standard. The beam and column only designed for your Indian standards. Okay, that is the important one. Your slab, the slab is a go for your American standard also. So, okay, our third step will be over. The next step is analyze. The next step is analyze. How to analyze your beams? Simply go for mode options. Okay, simply go for mode option, then go to member design. Simply click this automatically. The number will be there. Then add your beam on this design section. Next step, add your beams on your design section. Control select this member is automatically select this number. Right click on your mouse. Right click on your mouse. Add to design group. Add to design group. Add. Okay. It's automatically it will be add. Then go for design. Simply click this design. This automatically your number will be added. Simply click this design. Automatically the number will be added. Simply select this all the numbers. Simply click this design. This automatically this is a main table. This is our main table. This is our spanning conditions. This is our beam type. All are fixed beams. This is our hanging and sagging. The hanging and sagging are also pass. Then our shear bars also pass. Sometimes it will be fail. You go for redesign it. Okay. Sometimes it will be fail for your span by depth ratio or shear bars. Next one is span by depth ratio. The span by depth ratio it will be given. The all the conditions are passed for this. All the beams in advanced as the design. This is our beam is a hanging and sagging also pass. Then go to our shear bars also pass. Then span by depth ratio it will be pass for your materials. The next one is a design summary. Next one is a main layout. I need the reinforcement for my the same diagram. I need the main reinforcement for my beams. It's second layer. Simply select that main reinforcement. See, simply select that main reinforcement. Automatically, the value will be given. Same like that. Minimum 2 bars only. The 2 bars will be taken the bottom layer. Then sagging. Sagging also taken the 2 bars of 16 mm dia. This is your maximum and minimum reinforcement for your top bar and bottom bar in this advanced RC elements. The next one is a shear layout. This is our shear layout. Then go for shear reinforcement. This is our shear. This is automatically is a 5 meter beam. The 5 meters divided into 12 segments. This is called 12 segments. This is automatically 1 meter, 1.5. So 12 segments is divided into 5 meter beams. Okay. So this is automatically our shear. This is our shear test. The shear is a high in two corners, two end, but the middle of the portion the shear is less. The shear is less, the stress will be less. This is our shear stress diagram for this areas. Okay, this is the shear stress. How to see the shear stress? Simply go to click your shear layout, then shear reinforcement. These are the shear, then this is our shear stresses also. The reinforcement will be provided tunneling steps, then spacing. Also, it will be given. Okay, so all the values will be given. Two-legged 8 mm links will be given. Spacing 10 centimeter. Okay, 10 centimeter. Then AST will be given for your all the beams. Okay, all the beams it will be given. The next one is a schedule. The next one is a schedule. It's taken into cross section also. It's taken into cross section. This is our cross section. You will be changed to A4 size, or this is our A4 size. I need the A2 size, or otherwise other different sizes are available. I simply take into A2, sorry, A3 size, is A3 size, then change it to scale ratio 1 is to 10 or 1 is to 33. I change it to 1 is to 10. See this 1 is to 10. How to export your AutoCAD? Simply go for DFX file. DFX file, simply click this OK. Simply click this OK. Then go to simply click this OK, then save this file. With this, I save this file in my desktop also. This I save this file in my desktop. I simply click this save as a DFX file. DFX file, simply save it. It's automatically the beam design file. This type of reinforcement, the file will be there. So how to open, how to see the reinforcement detailing for your beam is automatically our DFX file will be there. I simply double click this my DFX file. Once you created in advanced RC, you will be created the reinforcement detailing also in this method. It's automatically it's give the three cross sections and all the values in this AutoCAD also. You'll be edited, change the value and all the things. Okay. Wait for 1 or 2 minutes. The AutoCAD file will be opening. Yes. Yeah. See this automatically. It's visible. This is our cross section and longitudinal section for your beam. This is a top zone. This is a bottom zone and all the zones also. You will edit it or change or anyone for this reinforcement also. This is automatically go to extra line. I need the extra reinforcement and all the things for you will be edit this detailing also in this CAD also. See this is our reinforcement detailing for this beam. This AutoCAD. This is our cross section. This is automatically this is our cross section. This is a mid cross section. This is a end cross section. Automatically it provided that this end and this end for extra bars. The bottom will be provided for this compression zone also. This is automatically it's taken into AutoCAD. The next one, this is a method to designing for your stat for this beam detailing. See, this is our T16. All the 16 mm dia will be calculated. The next one, the same like that, you go for your column design. Now it's a design as a beam design. The beam design, once you created the envelopes, members, and the groups and briefs, simply go for design. You will take the detailing in your AutoCAD also. Simply export it. then you are detailing in this AutoCAD also. The next one, how to analyze and design and detailing in this column design. Okay, next one is a column. Now itself is completed in this beam. The next one is a columns. Okay, next one is a column. It's the same procedure. Go to new envelope. I simply go to new envelope. This is our column design. This is our column design. I simply enter my name. This is our column design. Simply click OK. Then this side load changes into that side. The load case is changes into envelope side. This is automatically it will be selected. Then click OK. So is automatically it will be added for this combination load. Then go to second step is a member. You select your column numbers. First of all, you selected this beam number. The second one is a column numbers. This is automatically I selected any three columns. In this column, this is automatically I selected this three column. Then go for member. Give this auto form number. Then M5, M6, M7. M5, M6, M7 or M5, M6, M7 are column numbers also. Okay. This is our column numbers. Then how to design your column? The same procedure. Go to groups and briefs. Then go to design. You take the detailing diagram for your column also. Then you simply go for groups and briefs. Then you go simply go for your groups and briefs. The first step is a new brief. You simply go for new brief. Then go to this is our column design. This is our column design. Simply our code is a IS456. This is our IS456. Then design is a columns. Okay, change it. Change it. This is a design is a columns. The design is a column. Simply click OK. Simply click it. Okay. Then you change the all the values for your column also. All the values. The first one is a grade of concrete. The first one is a grade of concrete. My grade of concrete is a M20, M25 or anyone. I simply selected my M20s. Okay, my grade of concrete is a M20. This is automatically my grade of concrete is a M20. Then another one is a minimum spacing of reinforcement. I will do the 40 mm. Then our cover also same like that. I will be provided the 40 mm cover. Then main bars I provided the 500 mm. The five sorry grade of steel is the main steel is the 500 Newton per mm square. My links are I provided 4 on 5 Newton per mm. My grade of steel for my links is a 4 on 5. The main bars is a 500. Then minimum size of bar is I provided 16 mm. The maximum size it provided the 20 mm. The minimum size is a 16, maximum size is a 20. Then you go for your minimum size of this links. I provided the 8 mm. So, okay, provided the 8 mm for your minimum links. Then go for column factor. The column flatter, you will be simply your column is a bracing condition YY or Z type. You simply click this based on your bracing conditions. Then sturdiness is always 1. You will be calculated. Simply click this calculated. You calculate the effective length factor. I simply take this 1 on this axis. Then go to member load case. I simply select this number. The transfer to selected areas. I simply transfer to selected areas, then click OK. I simply select this OK. Then go to next one, new design group. This simply select your design group is a column design. Simply select your column design, then click OK. Automatically the column design will be there. Then same like that, go to member design. This automatically your column member design is there. Same like select this three members M6, M5, M7. Then right click on your mouse, go to add design member. Then go to this is a design group 2. Design group 1 is a beam, design group 2 is a column. Then click this add, automatically it will be added. Then click OK. Then click OK. Then go for design. click this design, automatically your column number will be visible. Automatically your column number will be visible. Then go for design, click this, automatically your major bars and minus all the will be, your check will be okay. This automatically your columns and all the major and minor check will be okay. Next one is a main layout for your column shear layout, all the values. Then finally you go for result value. The result is a M5, this column. This is a M5 column. The M5 column values are all the data will be given. M5, I'll go to our axial load. This is our axial load, the major moment. This is a minor moment. Your column design, then our AST, number of bars, 4 bars, it will be provided. The next column also load and provided and all the things also. The next bar is the axial load. Then next one is a major moment, the minor moment, then major also. The 4 bars of 16, it will be provided. Then next one is a shear y direction, x direction. Automatically, the shear value will be taken. This is our spacing. The stirrups calculation, it will be provided the 8 mm dia. The spacing will be given 25 mm, 250 mm spacing for your links for your stirrups. Okay. Next one, you finally go for schedule. The schedule is automatically, it is the drawing is exported into AutoCAD. I go to DFX format, then I get into A2 sheet. This is a A2 or A3 sheets. This is our A3 sheet. Then go to changes into 1 by 10. I simply A2 or A3, any sheets. Simply click this, change this, your ratio values also. 13.33 and 1 is to 25, 1 is to 20. I take this 1 is to 20, simply click OK. Then same like that, desktop you change into column. Automatically it's open on your AutoCAD also for your column detailing. This is our second column 002. This is our beam. This is our column also. So automatically it will be given for this column distance. This is our reinforcement. This side is a 2. This side is a 2 bars. It will be provided. Total is a, this is our reinforcement. You edit your based on your conditions also. Okay, this is the main reinforcement directly exported to your AutoCAD, then will be used. Otherwise you taken into your reinforcement, then detailing it directly go for your AutoCAD also. Okay, this is the main advantage for your RC design for your advanced RC design. Now it's clear how to analyze your beam and column in normal design and advanced RC design also. Okay, now let's discuss about the how to design your beam and columns. Then how to design your foundation footing. I tell about how to design your isolated footings. Okay, I tell about how to design your isolated footing in this stat foundation. I simply close this. I simply close this. Sorry, again I open this. All the I closes all the folders. Sorry. Then I will open that one more time. Now itself how to design your isolated foundation in stat also. Okay. Once you open, you go for analyze. Once you analyze this whole structure, okay, then you go for any design or footing design or any ones. Okay. Then how to design your footing? You simply go to this modeling toolbar, click this foundation designs. Okay, click this foundation design, then go to this foundation design option. There load case one, I take this my combination load. So okay, I take this combination load, I selected my combination load for my foundation. I simply selected the combination load, go to include option. I selected my combination load, then go to include option, then go to run stat foundation. Like this, automatically your all the footings values will be directly transferred to your foundation also. Wait for 1 minute, it will be directly all the node points and loads will be transferred to stat foundation also. Yeah. The stat pro will be transferred to all the node points and then loads and moments and all the things also. So is automatically this is our moment, and then load points is a load is a heavy, the moments this side and this side also heavy, the center portion is a minimum moment. It will be shown in this foundation. Our next step is a designing for your foundation. You will be created the same steps in foundation also. You'll be created the grid points, you will be provided the column position and the column dimension also. But the easy method, once you created in this staadpro, directly exported from that foundation, that is the easy one. But you will be all the things created in foundation, the grid line marking, column dimension, load also is more time to be taken. The easy one, you will be created the any model in this tab. Okay, you simply created the any model in this tab, directly exported in this tab foundations. Okay, directly exported in this tab foundation, that is the easy one. You go to load and factors, the load automatically your load and moment, all the things are directly transferred to your foundation also. So is automatically this is our load and foundation, it will be transfer for your area. So this is our load and foundation. This is our moment value is a smaller moment, is high, is a too high. This is our load, this is a small load, this is a small load, this is a heavy load. This is a symbol will be mentioned. Then how to design your isolated footings. Okay. How to design your isolated footing. Go for job setup option. You go for job setup option. The first setup is a create a new job. The first setup is a create a new job. Simply go for your job name. I will be created the isolated footing. Isolated footing. Job setup. I simply created the isolated footing. The next one is a job type. What type of footing will be chosen? Pile cap, mat, combined or isolated. I will be designed for my isolated footing for my building. The next one, design code. Design code will be used for American, British or Canadian. I simply select my Indians. Okay. Unit setting, automatically it changes into SI unit. You will be change your job name is isolated, then job type is a isolated, then design code is a Indian, then unit is a SI, and then go for assign this support to the load. This is available load case. I simply click this, go to I transfer to my selected load case. This is available load case, then directly selected to our central load case, then go to create job. Create job, automatically it's created the new created isolated footings. Okay, then click this, go to design parameters. Design parameters, there are three parameters are there: concrete and rebar, coil and cover and soil, the footing geometries. Okay, I tell about how to give the values for your concrete and rebar, cover and soil for your footing. The first one, concrete and rebars. Okay, the first one is a concrete and rebar. First is a unit weight of concrete. Our unit weight of concrete is a 25 Newton per kilonewton per meter cubes. Okay. Our unit weight of the concrete is a Newton per kilonewton per meter cube for 25 mm. Then minimum bar spacing I provided the 50 mm. Maximum bar spacing you based on your condition, you will be put the 150 mm or anyone, you will be changing unit also. Click this dialog box, automatically you change the meter or feet or inch or anyone. This is also Newton or kilonewton kg per meter cube. All the things will be changed on this unit on this side. Then you will be change this value also, maximum and the minimum value for your reinforcement also. Then strength of the concrete, my concrete grade is a M20 or 25. You simply fix it on your grade of work concrete also. Next, yield strength. Yield strength you will be go for, I provided the 500. The 500 Newton per mm square. You will be change the 415 or 550, 250 anyone. I simply change my the grade of the concrete is a 500 mm. Then is the maximum bar size. The minimum bar also 12, the maximum also 12. Sometimes you go for change into 16 also. Sometimes the heavy load will becomes you go for this 16, but the maximum you will be chosen for this 12 mm dia also, maximum minimum. The first step is the input value for concrete, your grade of concrete, bar spacing and minimum and maximum spacing for your conditions, then strength of the concrete, then yield strength, then minimum bars and maximum bars also. Okay, this is the first step. I will be simply change this all the values. Then go for the second one, cover and soil. The cover and soil is a your soil type is a drained or undrained. I simply my selected is a drained soil is a coarse aggregate. That type of soil is a coarse aggregate. Then our bottom cover. The cover of the footing is a 50 mm. Okay. I simply select my cover of the footing is a 50 mm. Then unit weight of the soil is a 18 kilonewton per meter cube. Do not change this type of values. Your columns and all the values is the 50 is the correct, is the 18. The next one is the very important soil bearing capacity SBC. Soil bearing capacity will be taken based on your soil test. Okay, you need a hard data is a 250 I will give, but I go for the my hard data is a 200. I tested my soil test, it's a final value is a 200 kilonewton per meter square. My SBC is a 200 kilonewton per meter square. The next one is a you will be changes depth of the footing, depth of the above the soil. I already excavated that soil. My depth of the soil is a 1500 mm above the ground levels. Okay, my depth of the footing is the ground level above the 1500 mm. This is the your this condition you will be changed only for water table or waterless area. You will be change that value. Otherwise, you simply change your soil bearing capacity is the important one, and then depth of the soil above is to will be changed on this second one, cover and soil. Otherwise, your cover also same and the unit weight of also same. This will be different soil bearing capacity and is above the soil. Then close it. The next one is a footing geometry. That is an important one. The footing geometry. The footing geometry is a footing type. I need a sloped type or uniform is a spread footing. You go for heavy loads, you selected the spread footing. I simply selected as a sloped footings. Okay. I simply selected as a normal sloped footing. Then I go for the design type. Design type is a calculate dimension, set dimensions. Calculate dimension means is automatically the stat foundation will be calculated for your dimensions and set dimensions, and you simply select this calculate dimensions automatically. The all the values will be calculated. You will be choose your what type of foundation is a sloped or spread. I simply select my sloped, then I put this calculate dimensions. Okay, then I go for my sliding and overturning. Our factor of safety totally 3. 1.5 is a sliding and overturning is a 1.5. So I already told that our factor of safety is a 3. This is our factor of safety. It will be given. Then finally you go for design. You simply click this design, give yes. This automatically it will be designed for your isolated footing as per IS 456 2000. Your footing will be designed for your IS 456 2000. Our footings are 146. This depend on your column sizes and numbers also. This is our column ID, group ID. This is our length of your footing. Our length is a 1.8 meter. This width is a 1.6 meter. Our thickness of the footing is a zero point 0.2 meter. Our thickness is a sloped thickness is a 0.112. The next footing is a 0.175, 0.165. The thickness is a 300 mm. The next one also same 0.1818. The thickness is the same. Okay. Then reinforcement. The bottom reinforcement will be provided the 12 mm dia, 7-inch spacing, and then bottom reinforcement for MX two directions, MX and MZ. Then reinforcement, top reinforcement also you provided the MX and MX also 12 mm dia bars for 7-inch spacing also. Then how to see the diagrams for your stat foundation? The first one is a geometry. You simply click the second one, detail and schedule drawing. This automatically it will be given on this detail drawing. This is a elevation view. This is a plan view. This is our plan view is a 1.8 into 1.65. This is our bottom reinforcement diagram will be given. Then this is our elevation view. This is a elevation view. This is our thickness 0.25. Total slope is a 0.115. This is the depth of the ground level. Ground level above the footing height is a 1.5 meters. Okay, this is our elevation view and plan view. For this, all the footings will be given. Says all the footings will be given. Is directly save on your file also. Simply go to save drawings. Is automatically saved into AutoCAD file or image file or anyone for this drawings. Okay, you simply say this anyone file is a vector file. You will be change this AutoCAD. Sometimes otherwise you go for your image files are anyone you will be save this image files are the types of files are easy one. Okay, simply save this type of diagram. This is the our detailed diagram. This is schedule diagram. This is schedule diagram means the three footing will be dimension will be given. The sizes, length, breadth and thickness, all the values will be given on this schedule drawings. Okay, all the values will be given on this schedule drawing also. Next one, the GA drawing, graphical drawing. This is the first drawing to provided the center to center dimension column marking drawing. The graphical drawing. This is the first drawing to be given for your sites. Is our center to center distance 4 meter is a 5 meters is our column dimension. So 1, 2, 3 is our column. F1, F2, F3 is a footing name. Then see this is our F1, F2, F3. This is a footing dimension. F1 is a 1.8 into 1.6 into 0.25. Then 2 is a 1.75 to 1.6. Then F3 is a 1.8 to 1.6. Okay, next one is how to check your. I already told that some calculations. There are three checks are made: the bending moment, one-way shear, and a two-way shear also. The staadpro will be calculated same as a manual also. The staadpro will be calculated as a manual like that. You simply go for this bottom. This is automatically this is a footing one. This is a design calculation. Your footing is a first footing. Footing one automatic the value will be taken. The slope dimension all the values will be taken. The finally it will design as a moment design is all the values will be taken for your pressure distribution and all the sliding values. First is a critical trial depth against the moment. You simply calculated the trial depth against the moment. The structure will be safe. The next one is the same two direction, x direction and z direction also. The z direction also it will be safe. Then you go for your one-way shear. One-way shear x-axis also safe. The two direction is a z-axis. Z-axis also shape for your two-way. Then next for two-way shear. Two-way shear also safe. Then you go for your calculation, reinforcement calculation, x-axis and z-axis and all the things. This is the procedure to create the all the footings. Footings on which compulsory you go for your footing design. Check your one-way shear, two-way shear, and bending also. The StatPro will be follow on the same like that in this manual. This automatically it's created the calculation sheet, GA drawing and detail drawing, and finally it's a geometries. Okay, now it's clear how to create this values and how to take this. I need this GA drawing. Go to save as option. You will be save the vector file or otherwise graphical PNG format. All the files are available. Simply click this. Simply save on your file also. The next another one footing I tell that how to create the combined footing also. How to create the combined footing in STAAD Foundation. Now it's created the isolated footing. This is our isolated footing. The next footing I will be created is combined footing. First of all, go to job setup, create new job. We have to create the combined footing. Go to create new job. Simply select our footing is a combined footing. Job type. Select your job type is a combined. The name will be changed combined. This is our job type is a combined footings. Okay, this is a combined footing. Our design code. Design code also you will be changed into Indians. Okay, simply change the design also will be taken into design as a Indian. Then you go change automatically SI unit. The next step also same, the load case. The load case will be selected, then transfer into selected load case. Simply select a load case, then go to create job. Click this automatically, it's a create job. Then combined with the two footings, which footing you will be combined on it. First of all, select this two footing control and select this two footings. Okay, select this two footing, then go to create forms and selected footings. Okay, simply select it automatically. Your slab type of combined footing will be created. Then see this footing one. Automatically footing 1 to 2 will be taken as a combined footing. Then how to design your combined footing? First of all, you created, then go for combined footing. Go to design parameters, same like that. Cover and rebar, cover, soil and safety, footing, geometry also given. The first one is a concrete and rebar. Same like that, your unit weight and a bar spacing. Maximum bar spacing, it's go for 400 mm. It's a slab is there. So it's go for 400 mm. The strength of the concrete, the grade and maximum bars and minimum bars. Same like that. Isolated footing. Then cover soil. This is our pedestal cover also. Same footing cover. Unit weight, our SBC values. The SBC value is 250. I change into 250. Our depth of the footing also 1800 mm. Okay, 1800 mm. The next is the footing geometry. The footing geometry, you simply click this calculate dimensions. The calculate dimensions automatically it's taken into your footing design also. Calculate dimensions, it's automatically it changes into footing dimensions. Simply click this. First concrete and rebar. Next one is a cover and soil and safety. The next one is a footing geometry. Simply select your footing geometry. Then go to finally click this design option. Yes. Design option. Yes. Automatically it's create your the combined footing as per IS 4 basic. The summary will be given. This is automatically our left to overhanging, right to overhanging length. This is our footing length. This is a length is a width is a 6 meter. Our length is a 6 meter. Width is a 2.5 meter for our footing. Then thickness is a 0.5 meters. Okay, all are in meters. Our length is a 6 meter, then 2.5 meter and a 0.5 meter also. Then main steel is provided for 12 mm for 7 inches. Then main steel bottom, secondary steel bottom, all the steel bottoms are will be provided. The same like the manual calculation also for your combined footing. The main checks are corner pressure and all the checks will be followed. It will be along this actual flexural. The slab will be there. So you check for your flexural is a two-way shear. The two-way shear and then it will be pass, hence safe. Then you go for your reinforcement, two-way shear, then one-way shear and all the things also. Then same like that, go to detail drawings is automatically is a combined footing. This is our diagram for this detail drawing. Click this detail drawing. This is our plan view. This is our plan view for your combined footings. This is our 6 meter. This is our 2.5 meter. This is our center to center distance. Is all the distance in this elevations. This is our center to center distance and all the distance in this area. The thickness is a zero point 0.5 thickness is the ground level. This is our combined footing design. Then GA drawing. This is a GA drawing for your combined footing. Then calculation sheets and a graph also. Shear and bending for your combined footing. This is our slab is there. This is our slab shear diagram for your area. Then this is our bending moment for your combined footing for your slab also. It will be take the diagram for your save image option. It will be take the all the values for your images and the values also. How to take this value? Simply copy and paste in this word also. It will be taken for this all the things. It's a easy one. You check this manual in this Excel sheet, also in this foundation. You check that. Once you check means you go for directly check that bending, one-way shear and punching shear also. Now it's clear how to analyze your advanced RC elements. Then footing design for your stat foundation. This is same like that you will be follow for this any structure. It's the same procedure, but you refer the different code books and manual calculations also. First of all, discuss about the lateral calculations. Same like that, you will be follow the lateral calculations also. Okay. Now it's clear how to analyze your RC, advanced RC. Then how to design your normal isolated foundation and normal combined foundation also. Okay, it's clear. Okay, fine. Now itself, I completed this section now itself. Tomorrow will be discuss on how to create the one 3D structure. So okay, 3D structure, 3D framed structure. Then it's the same like that. You apply the loads and all the things also same like that. But I tell about how to create the 3D framed structure. Today, tomorrow is the last class. How to create the 3D framed structure for G+3, and then how to take the reports like bending moment diagram, shear diagram, and reinforcement diagram, and all the things also. Okay. So once again, thank you all. I put the attendance form in chat box. Please fill this attendance form. So once again, thank you all.